Monday is here, a new day, a new week to propel us to success and happiness. Good morning, everyone. Dear professors, welcome you all for the day 6 of AICTE-ISTE sponsored 6 days refresher course on Anaconda Data Science Techniques. The agenda for the day goes as follows. First session will be on Introduction to CNN Model Hands-on CNN. Second session will be on Introduction to RNN and LSTM. And at end, we have photo session. In the afternoon, we'll be having valedictory function. Without further ado, let's get started. The 16th session about Introduction to CNN Model Hands-on, it will be handled by Dr. Abhishek Kumar. It gives me an immense pleasure in introducing our resource person, Dr. Abhishek from Chitkara University to the gathering. He is a doctorate in computer science from University of Madras and done M.Tech in computer science and engineering from Government Engineering College, Ajmer, Rajasthan Technical University. He has over 88 years of academic teaching experience. He has published more than 80 publications in reputed peer-reviewed national and international journals. He is currently working as an assistant professor in research, Chitkara University, Himachal Pradesh. His research areas includes artificial intelligence, image processing, computer vision, data mining, and machine learning. He has been the review for IEEE and InterScience Journal. He has authored and co-authored nearly 6 books, which is published internationally, and edited nearly 20 books. He is a patent holder and got Sir C.V. Raman National Award for 2018 in Young Researcher and Faculty category from IJRP Group. I thank him for providing his gracious presence to join us today. Now, I request our resource person, Dr. Abhishek, to proceed the session. Over to you, sir.
Okay, ma'am. Thank you so very much for a very warm welcome and a very happening introduction. I would like to thank the college management for inviting me again. I have been here before also, and Professor Anand for being a very good associate for a very long time. So without wasting my time and your time also, we will start it and we will have a healthy discussion. This is nothing like delivering a lecture. This is like interaction from different platform, from different organization to have some healthy discussion over it. So I would like you to respond positively so that we can have a healthy discussion. So we will have a very good discussion afterwards. Before 15 minutes, I'll allow you to ask as many as question you want me to ask. So let me share the PPT with you so that I can start with it. So I hope it is visible to all of you. Yeah.
Yes, sir.
Okay, perfect. So here we come. What I'm gonna do, I'll use MS Office also to explain something which is not possible in PPT only. So basically, we will start with CNN. Fine. So we will have a very good session. That basics of CNN is very important. I must tell you. So basics of CNN.
If you make it full screen, it will be good. Please make it full screen.
Okay, I'm doing it, sir. Now fine?
No, sir. First you make it full screen, then you share, then it will come. First you open the PPT, make it full screen, then you share.
It's fine now, sir?
No, sir. Still it is not full screen.
Okay.
Okay, anyway.
Excuse me, sir. You can share your entire screen, then you can show slideshow, sir.
Okay, okay. Because I
Yeah,
have to come back on my that is this doc file.
yeah, yeah.
Let
Yeah,
me
you can share your entire screen so that even if you switch to other documents, it will be visible to the participants.
okay. Now it's okay.
Yes, sir. Yes, sir.
Yes, sir.
Okay, perfect,
Perfectly right.
perfect, perfect. Just wait for a minute. So yeah, so we have to start with this. What is CNN basically? So we have to go through with we do have machine learning before. We do have many other machine learning models also. Then why we have moved to convolutional neural network? So basically, it is totally based on human brains. And if human brain is that much capable, what is need of artificial neural network or artificial intelligence? That's my point is. So we will start with it, and then we will move to that how it can be implemented and what is the need of implementation, how it should be implemented with the some new concept, because whenever you have gone through with the different kinds of paper you will download it and you will have it, then you will find it that there is no new efficient algorithm has been proposed so far. Getting my point? So my point is we need to follow the conventional algorithm and then we have to move forward. That's the thing is. So basically, when we have to do the introduction part, we all know that CNN is a neural network, basically based on human brains. The basic reference is human brain. Again, I mean, it is just a neural network that has one or more convolutional layers. What I mean to say, they are mainly used for image processing. Getting my point? They are mainly used for classifications, they are mainly used for segmentation, and also for other auto correlated data. Getting my point? So that is the basic point. Now the question is how many input layers should be there, how many hidden layers should be there, how many hidden layers should be there, and what should be the output layer. That's all our very connected question that we have to bother about when we are dealing with CNN. So before getting into it, we must know that a convolution, when we are talking about a convolution, it is essentially sliding a filter over the input, right? Whenever we are talking about convolution, it is essentially a sliding, you have to slide a filter over an input, then you have to wait for the output, and that's it. So basically, the most or one of the most helpful way to think about convolutions, fine, is to if we are saying that we have to slide the filter over the input. First of all, I have already discussed with you. So one researcher, Dr. Prasad, he is from basically he's from India, but he has done research from in USA. So he said that a convolution can be, I'm not exact quoting what he has said, I'm just getting you the postulates what he has said. So a convolution can be thought as looking at the functions surrounding. Getting my point? As you can see this status here. So looking at the function in the surrounding to make better and accurate predictions of its outcome. So prediction is still there. Classification is still there. So the main question, the question arises that why we have moved from machine learning to CNN. So my point is basically if we have started it, so I would say that data set, if we are having a bulky and very big data set in which machine learning algorithms are not efficient enough to handle it or model it, then we have moved on to CNN. But I would rather say that you must agree, everyone who, all dignitaries, research scholars and professors and assistant professors, you must agree to me over this issue that have you ever seen some, algorithm which has been proposed apart from the layer changes or pooling layer changes or anything like that has been issued, like in machine learning we are having PCA. So there are lots of algorithm which has changed PCA. We are having LDA. So there are lots of algorithm even till nowadays. They are working over it. So they have changed the algorithm theory wise, implementation wise, and even proved it mathematically. Most of them has not proved it mathematically, but somehow 50 or 60% have proved it. So if we have to quote it along with the different researchers quotation, so a convolution can be thought as function surrounding based on brain mapping to make better and efficient predictions comparatively. We must consider this term comparatively because there are lots of algorithm and they should be compared. They have some their own case studies. So we have lots of parameter to work on. Fine. So we cannot say that this algorithm is good in all the conditions. So we have to go through all the conditions, all the surroundings that surrounding is all about, and all the parameters we are using, and all the parameters previously in the existing work researchers have used. Getting my point? So consider a learning image as this PPT is showing you. Some patterns are much smaller than the whole image. That's what I'm talking about. Fine. So if we are having lots of images like this, then only CNN is applicable. It should be applicable only then. Otherwise, it would be a wastage of time. It would be a wastage of manpower. It would be a wastage of cost if we are making some algorithm on a small data sets. Machine learning is itself very compact and itself very contained to go for that recognition and all. Fine. So basically, rather than looking at the entire image, if you are seeing it, fine. So rather than looking at the entire image, what we are doing at once, find certain features that basically we also teach to our students of BTech, that we have to find some specific feature which we have to tally, which we have to recognize, which we have to detect. Fine. So once we have find a certain feature in this particular image, as you can see over here. Fine. It can be more effective to look a smaller portion of the image. That's my point is. Fine. So suppose I'm moving my mouse over here. If you can see it, suppose we have to recognize the retina only, and we are having test set and training set. So it should be having normalization there. Otherwise, they both are being the same image. They will appear to be the different. Getting my point? Even if you are applying machine learning, even if you are applying CNN, that will not matter. Fine. So basically, if you will ask me this, then what is the use of classification algorithms like PCA and all? Why we are using it? What is the point of using those algorithms? Why we are using it? So the point is they have their own certain limitations. So beyond their limitation, they cannot use, and that's the problem formulation for your work. So if you are working, you have to find what is the limitation. Always, I would prefer. What is the limitation of the existing work? Why it was limited to it? And then we have to find that how it should be processed. Getting my point? So now it is getting detected. Now you can see beak detector. For example, we have to detect the beak. Fine. So it is getting done. But if it is retina, it will always give a wrong answer. Fine. So we can represent a small region with fewer parameters. That will be very good. But the fewer parameters can be represented using machine learning also. Then what is the point of this? So we all have gone through with array concept, right? We have gone through array concept in C, in C++, in Java. So what we are doing here in CNN, we will make a array of images. What array was doing previously? It was taking data type should be same, homogeneous collection of data. Remember? So the images should be of same type, The images should be normalized enough. The images should be, having same data size. So if they are having an array in the same image, now CNN can be applied over the array collection, and it should be having 10,000 image. It can be 1 lakh image. The CNN modeling will be work on that, where machine learning got failed. So basically, PCA, if you're talking about PCA is what PCA is doing in machine learning, it will convert n into n matrix into n square into 1. Basic work, man, that comes naturally to it. N into n matrix into n square equals to n square into 1. Everybody should, should we agree with me? If there is an issue, you can ask question later. You can write it down. So when it is n square into 1, what is the benefit of getting it through? The benefit is we have to go through only by row or by column. So it will definitely save the time. When we are dealing with the covariance matrix now, it won't take that much amount of time now. So time saving, fine. And we have to detect the smaller pattern. We have to detect the lesser data set having the same information. So these are the things we need to focus on, that why we are using it and what were the limitations of previous work, that we tend to move towards the CNN. Getting my point? If you are having a bigger data set, a bulky data set, then you would have problem. That's why CNN came into picture, and it is basically used for the same thing what we have used before. So as you can see here, same pattern appear in a different places. So they can be compressed. That's my point is. So the question is, what about the training a lot of such small detectors and each detector must move around? Ye dekhiye. Sorry, I have used Hindi word. So just look at this. If we are seeing it, if we are having large number of images in the same manner, then we need some better algorithm or some better modeling algorithm which can model it better and give me an efficient result. So if we are talking about the common uses of CNN, so the most common use of CNN is image classification. Always remember that. Whether you are working on healthcare data, whether you are working on, lungs X-ray, whether you are working on, tuberculosis, CT scan. So any kind of thing you are working on, it should be, if the input or if the probe image is, should be an, class images, fine. Then we are very much, reluctant in using machine learning algorithm. Then why we are opting for CNN? Just because the data is getting bulky. I'm telling you an example. The data mining was very much, content, but it should have, it was having its own limitation. That's what, when there is a concept of big data came. Then big data is handling bulky data. Although they are doing the same thing, although they are using the same algorithm, in most cases, if you are agree with me. So basically the same differences should be established by using that reference in this case also. Getting my point? So that's my point is, whenever you are doing it, you can go for CNN only and only when you are having a bulky data, and the data set should be refined enough, the data set should be classified enough, the data set should be pre-processed enough. Otherwise there is no point of using CNN. That's my whole concept is. Now the most common use is image classification, I have told you. For example, as you can see in the slide also. So identifying, now moving to some other image example. So suppose apart from slide, I'm giving you another example. Suppose you have to identify a satellite image now. Fine. So most of the cases in satellite image processing or in satellite imaging, you must have gone through in different papers, or your friends have been doing their research in that. They must use CNN because there is no point of using machine learning algorithms. They are not capable of handling those data. Fine. So suppose you are identifying a satellite image, so that must contain a road or a classifying hand. Fine. So I'm just taking this example in PPT and you will get to know that how it is applicable in different test cases also. So it should have some road in it. It should have some classifying hand, written letters and digits, getting my point? So it should be their object detection. At the same time, it is texture recognition also. So we are doing a several multi-purposes thing in a same example. Fine. So in example, you are doing a big detection, but in any image, you are exactly getting the things from the matrix it is having. So it is basically 0-1 game. It is basically a mathematical game when we are dealing with two matrix or more than two matrix. We are comparing it. We are making a covariance matrix out of it, that how their internal data are interrelated with each other, how their signals are interrelated with each other. So these are the things we need to take care of while getting through the detection. Whether you are doing it in MATLAB, whether you are doing it in Python, that is a secondary matter for sure. Fine. So my point is, the summary of those 3 slides, what I have shared with you is that we have to consider initially a very small portions, a very small matrices. Fine. That will make the things much more efficient, and that will make the results much more efficient. So when we are talking about satellite image, the whole scenario will be changed now. So the whole scenario will be changed. So they are quite mainstream tasks. What I have talked to you, that letter, digits, or what I have told you, road, fine. So they are mainstream tasks. We cannot ignore that. So in such case, image segmentation should be needed. Signal processing should be needed. So it is not just CNN. It is image segmentation, it is signal processing, image detection. These all comprised together to make CNN successful. Lots of researchers, even though not considering CNN a very, very efficient, if any kind of research they are going with, because they don't have any algorithm apart from the layer. And so it is more working like simulatory. You have to go on GIT Hub, you have to download the code, and you have to make some functions related to it. That's not research. You have to make changes in the algorithm, what you are using. You cannot use some other person algorithm in your work. That is not work. That's my point. So even if you are doing it in a very small way, it is worthy. It is a worthy game. Fine. So now I have explained that we were having different tasks in the same image of satellite. Here in a bird image, we are having a smaller task. That's what I am emphasized that we have to use the smaller task only in initial phase. But at least in the mid phase or in the last phase of your work, you have to go through with bulky data. We cannot perform our whole research on a single data and doing the things which is supposed to be done in BTech time. Getting my point? So now when there is a multitasking, then here is we are having CNN came into picture, and we have to rely over CNN in that case. Fine. So there is image segmentation to segment the image in required format. Whatever you are needing, what portion you are needing, you are getting into it. So whether you are doing it in any tool, image segmentation means the same thing. Fine. Just then there is a question. You just write it down. I'll ask you later. What is the difference between image segmentation and removing noise from image? So this is the first question we are having. What is the difference between image segmentation and removing noise from image? Are both doing the same thing, or there is some difference? If there is some difference, just think it of and just let me know later. I'll write it down also in later phase. So my point is that when you are supposed to use CNN, it should be have bulky data set, it should be have bulky task, it should be have mixture of many algorithms together, then CNN can perform well at. Fine. So that's my thing is. So here we are saying that they can be compressed to the same parameter. If you are taking the same parameter, the things will be very much okay for you in the latter phase also. Getting my point? Now there is a convolution layer. What is that convolution layer? So the soul of CNN neural network is convolutional layers and some other layers also. We will discuss over it. So a convolutional layer has a number of filters, right? That's what I have been emphasized on, that we are playing with filters, pulling layers, we are changing it and we are doing our research. But that's not the thing we have to go for. Even if it is not possible, we have to go for some other algorithms, some other tools also. We have to request a university like MIT, Stanford. They are providing it virtually. I have used that. They have provided it virtually for 1 month or 2 months for free of cost if we are from underdeveloped nation or underdeveloping nation. Getting my point? So you just have to make aware yourself that we should not be limited to the tool, that we have only Python to go further with. I mean, most of the colleges are having their AI lab, so there are many other things which we can rely upon. Fine. So these are the basic soul of convolution layer if we are talking about. So if it is weak detector, so it is a very, I mean, basic test image, and it has to be considered as input probe image, and it has to be applied with filters and layers stream, and then we will get the output, and that will be finalized at that this is the final output we are having. Fine. So if we are talking about convolution, so I'm talking about we are only doing research on maths or on metrics. Getting my point? So I'm coming over it. So basically when we are talking about CNN have been used for understanding in NLP, speech recognition, fine, just getting it through. So there are very multi-purpose applications of CNN. So NLP is itself a very wide domain. Fine, if we have to study it or we have to deliver lecture for it, at least 1 month is less. So speech recognition is there, object detection is there, although of an NLP recurrent neural network, RNN, you must have heard about this. So NLP recurrent neural nets are also used when you are dealing with NLP. So the domain is very vast, but most of the work which you have been noticed, it is done in healthcare, in oral cancer, in breast cancer, in COVID detection. These are the things. You should be go through with one paper. Even that paper is done by me only, and that paper we have applied CNN, and it was in initial phase of COVID. So it was having certain limitation, and it was a review paper actually. So I'm not going to, promise you that it will be a very good paper and we have proposed a new algorithm in that. But most of the paper we have proposed an algorithm. In that paper we have not proposed because COVID was not very new at its time. It was published in 2020 only. So my point is we have just applied the inbuilt algorithm what we have before also, but we have mentioned some limitation and some outcome of that paper. That was mattering. Fine. So my point is you have to think about those dimensions also. If we are talking about CNN, a CNN can also be implemented as an unit architecture. Fine. Which is almost, it is essentially, which is almost a mirrored CNN resulting, having the same results. Although I have not used that, but you can use that, resulting in a CNN whose architecture, as you can see, the basic thing in the PPT also. Fine. So whose architecture can be presented in a very U shape. So in case of units or unit are used where the output needs to be of similar size of input. Just see it. Output needs to be of similar size of input. That's what I have explained in the array concept. Otherwise, it will never give a very efficient result. So suppose we are doing some segmentation over input image. for or doing some image improvement also, these things should be matter. That's the whole scenario is. So this is the point I want to discuss it with you. You just have this, that what is the role of filter in it. Fine. So if we are going through with 0 to 1, we are having only 0 and 1, and with a black pixel and white pixel. If we are having some other data in it, we have converted it from 3D to 2D, whether it is Python or whether it is MATLAB. So when data lies between 0 to 1, it should be grayscale image. When data lies like 0 and 1 pixel, it should be in white or it should be in black. It should be black and white image. So there is a difference. Both are 2D image, but one part I am explaining is black and white. One part I am explaining it is a grayscale. Now the question arises, why we are getting into grayscale? What is the need of that? Because 3D image cannot be operated for segmentation, cannot be operated for normalization and other things. Because we have to normalize the things, so we have to convert it into 2D cases. Okay? So when these are the network parameters to be learned. These are the network parameters which should be learned in initial phase. So each filter detects a small pattern, 3 into 3. So we were having 6 into 6 image. Now we are having 3 into 3. We have changed it, we have converted it, and it could be random. So when we are talking about convolution, we are on convolution. Getting my point? So when we are talking about convolution, each convolution layer contains a series of filters, as you can see over here. Each convolution layer contains a series of filters known as convolution kernels. Fine. So you must have gone through with SVM kernels, right or wrong? Just like that, we are having convolution kernels. We must have some backpropagation, we must have some learning model, we must have some training algorithm in any kind of situation we are dealing with, some images or any kind of data set we are having. So that particular learning algorithm is convolution kernels. So when we are talking about the filter, as you can see in the image, see, this is filter 1. So the filter 1 is a matrix of integer. Fine, as you can see here, the filter 1 is a matrix of integer that are used on a subset of input pixel values. Clear? So at the first time, it is used for a subset of input pixel values, the same size as kernel is having. The same size, nothing gonna be changed. If it is gonna be changed, we are going in a wrong direction. Just have a look over it. Yeah, just see it. So each pixel, as you can see over here, each pixel is getting multiplied by the corresponding values in the kernel, whatever it may be. Fine. So, when we are multiplying it, corresponding value in the kernel, as you can see it over here, that the dot products we can also say, or we can give it back. Just this is for filter 1, this is dot product we are doing. So this is 3, size 3, this is for size 3, this is, we are getting answer for it. Fine. So we have to choose it. We are doing segmentation also. We are doing different kind of things also in the same part. So if you are able to understand what convolution is, basically, you will be able to solve any kind of problem, or you would be able to make your own function for any images. You can make changes in the algorithm, actually, what I think. Fine. Now, if we are doing this, now you can see it. We are doing this. Let's try one. So we are having different values. Getting my point? See. So everything is getting done like that. So we are playing with the matrix. Fine. And now I'm explaining what we have done before that. So suppose we are having this and then having this as a value, and then we will cut it off. So basically what we are doing, I have just told you that we have to multiply it with the corresponding value of the kernel. Now what we are doing, the result is summed up for a single value. Fine? Just like the image processing basics we are doing. For simplicity, representing a grid cell. Now we are having a grid cell like a pixel. Fine. So it is the basic, the basic unit is pixel here. Just like cell is a basic unit of our body. So we are playing with pixel and pixel intensity only in this game. So grid cell like a pixel we are having, and in the output channel or feature map we are seeing it. So how filter is playing a very important role. So these are basically linear transformation. If you have, got to recall it, this is actually a linear transformation. So each convolution, what we are doing, each convolution is a type of affine function itself. Fine? So affine, affinity, if you remember, for 2D image, for 3D image. So these are the things we are having. So just have a look. They are getting the same thing over here. Getting my point? So in computer vision, the input is often a 3-channel RGB that I have explained to you. For simplicity, we take a grayscale image which lies between 0 to 1. The pixel value lies between 0 to 1. It is not exactly 0, it is not exactly 1, not exactly beyond that. It should be lies between 0 to 1. Because the quality of the images lies between there, the pixel intensity. So whenever you are performing restoration, whenever you are performing picture improvement techniques, it will not get distorted. You are getting exactly the same output, the same output we are looking for. So for efficiency, we have taken a grayscale because it is a 2-dimensional matrix for sure. And for 3x3 convolution kernel, what you are seeing it, fine. What we are doing it, a 2-dimensional matrix it is also. So kernel stride, as you can see in the slide, the stride. So the kernel stride over the input matrix of the number moving horizontally, right? We are getting it right? So it will go through column by column. It will slide it, it will scan it over the first row in the matrix containing the image pixels value, then second one, then third one, and so on. So that's what I have explained to you. PCA will go with either with column or either with row. So even if in 12th class syllabus we have gone through with the matrix, so it should be either we will go anyways by row wise or by column wise. We will get the same answer. So that's the basic feature it has taken when we are implementing it in an image also, or on image pixel also, or on pixel intensity also. So any kind of thing you can apply it over. So now you can see the kernel stride down vertically to subsequent rows. Is it? The kernel stride down vertically to subsequent rows one by one. But you have to note it that the filter may stride over one or several pixels at a time. So this is a basic detail we are having for you. But if you are considering, suppose you must have got this in your mind, what if we are considering it for non-vision applications? It is a vision application. What I have explained to you, it is here only. Repeat this for each filter. Fine. And then we are getting the answer for different strides we are having. So this is the case we are having. We are giving different map. Now we are having feature map. So I'm not moving from my main motto. The motto is, you can ask me, what if this is applied on non-vision application? Then what will happen? A single line answer. A 1-dimensional convolution may slide vertically over an input matrix. That will the only change we have to implement. Otherwise, rest should be the same. Fine. So it should be vertically over an input matrix, and then second one, and then the third one, and then the fourth one, and so on. So basically the working is like this only. Fine. Fine. Now input, kernel and output. I'm showing you an example. Let me go in back PPT. Then you can have a better perception of what I'm trying to say. This one. So what is written there in A filter? Fine. What is written there in A filter and what is written there as input and output? So A filter is kernel. Beak detector is getting happened with the help of kernel. So you have to consider that when we need to create a feature map from a convolutional kernel, then we have to use it over here. I'm moving the mouse over here. We have to use it over here. Fine. If it should be, it should be kernel. So this diagram showing the operation of convolution kernel, if there is kernel instead of a filter. So just please don't confuse. If we are having kernel instead of a filter, it is showing an example of convolution kernel, that how kernel is working. So all the minute and extensive calculations will be done by it, and then we are having some value in the matrix, and then we are performing the algorithm or different implementation over that particular values. Fine. Even if you are doing it in simple image processing, even if you are doing it in machine learning, these are the things we are having, and these are the basic things we have to go further with. So basically, what my point is, we are using a stride word. So a stride one, 3 into 3, as you can see over here. So it is a convolution kernel. It is acting on 6 into 6 input image, right? What input image is having? 6 into 6. It could be 8 into 8. It could be anything else. Fine. So it will, if it is acting on 8 into 8 image, the outputting should be 8 into 8. If it is acting on 6 into 6 image, the outputting should be 8 into 8 filter or 8 into 8 channel. Fine. Whether we are doing image segmentation on a small portion, even though. So these are the visualizations, showing the kernel working, scanning over the values of input matrix. So these are scanning of the kernel. Everything is getting done by kernel. So this is a visualization basically for excellent presentation that how kernel is scanning over the values of input matrix. Fine. Even if it is a texture recognition. Even if it is a texture recognition, we need not to bother about it. We have to go for it. So each convolution layer contains a series of filters, as you can see over here. We are working on a filter 1, then we have to go for the filter 2 and for the filter n. Fine. So if we are having series of filter, these particular filters are known as convolutional kernel. That's why I have replaced that A filter with the term kernel. So the filter is a matrix of integer, as you can see in the slide also. The filter is a matrix of integer itself that are used on the subset of input pixel value. So what is input pixel value? These are the input pixel values. So the same size as of kernel, each pixel is multiplied by the corresponding value in the kernel. Getting my point? Then the result is summed up, like I explained before, for a single value for representing a grid cell like pixel. So again, we are representing pixel and pixel intensity. So whether it is feature map, whether it is output channel, it should be of the same size of the input. Now there is a concept, I'm getting on the next PPT now, there is a concept called padding. P-E-A-D-D-I-N-G, padding. So any answer for this? Actually, I cannot see by doing the things. So when we are having this, we can understand it better. So when we are talking about padding, so when we have to handle the edge pixel, there are several approaches. Fine. Whenever we have to handle the edge pixel. It is very, complicated and very much important task. We cannot skip it. Otherwise, the data should not be detected in the right manner we want it to detect. So to handle the edge pixel, we are having several approaches. The first approach is losing the edge pixel. We have to lose the edge pixel. Fine. Again, the things are getting that filter 1, filter 2. The same thing will be used. Don't worry. I'm not, moving down my own concepts, what I have told you, that what I have got from my experience of working. So we have to follow the same experience. We have to follow the same concept. So when we are dealing with edge pixels, we are having one basic concept, that is losing the edge pixel, the first one. The second one could be padding with 0 value pixel. So what does that point mean? Padding with 0 value pixel. If you are doing something, or if you are doing sum of something to 0, what does it mean? Any answer for that? You can unmute yourself in a way and you can tell me. If you are summing it up to 0, that means normalization. That means you are making the mean value equals to 0. The normalization means even if you are having different conditions where you have taken the input source, it will be normalized for getting it performed for the further cases. So now you can use the algorithm with same parameters. So you have basically normalized it. So when you are performing padding it with 0 pixel value is just to making the mean value to the 0 part. Fine. The third point is reflection padding. We will see that what is reflection padding. So losing the edge pixel is to just what PCA is doing, just dimension reduction. You are focusing on some specific portion. But when we are talking about reflection padding, fine, so you can see it over here. We are having image, we are having convolution, we are having fully connected parameters with the output also. So what is the difference? You can see it. We have performed a specific portion over here in this case, so it will always give a better result in that context. Otherwise, it has its own benefits. But when we are talking about a reflection padding, so reflection padding is by far the best approach where the number of pixels what we are dealing with needed for the convolution kernel. So when number of pixels are needed for convolution kernels, the process, the edge pixel are added in onto the outside. Copying the pixel from the edge of the image. Suppose, for example, you are having on your screen that 3.3 kernel you have dealt with. 3 kernel you have dealt with. Fine. Now we are having this also. So it is also 3 kernel. Fine. So you can see the changes, the output. I'm getting into the point where we have discussing it. 6 into 6. The same thing will be happen. Fine. So now we have to do, suppose we are having 3 kernel, what I have just segmented it, just see it. 1 pixel need to be added around the outside. In the same case, for 7 kernel, then 3 pixels would be reflected around the outside. So the pixel added around each side is the dimension, halved and rounded down, as you can see in the screen. Dimension, halved and rounded down. Dimension we have got in all the way, halved because we have to focus on certain or some specific part to get efficient result out of it, and rounded down to detect it well, we are percepting it down. So what we are conveying that we have to go for divide and rule concept, isn't it? So we have to go for divide and rule concept. So traditionally, I've always focused on what traditional approach was. Fine. What existing approach is, what new approach is saying. So traditionally, in many research papers, the edge pixel are just ignored. which should not be done. Just write it down and we can have a debate over this. I'll justify my points. So which loses a small portion of data. In that way, we will lose a small portion of data, right? And this gets increasing worse. In each case, we are approaching it. And if there are many deep convolutional layers, so for this reason, I could not find existing diagram to easily convey some of the points here without being misleading and confusing stride 1. So when I have done and confusing stride 1 convolution with a stride 2 convolution, fine. But padding is needed. With padding, the output from the input having the same width, having the same height, and would be width W and height H, the same as input, with a single input channel. That's my point is. So assuming the kernel takes a stride of 1 pixel at a time. So now we can have, if we are doing it, I'm just moving it down. Let me share one thing with you. That doc file. Is it visible to all of you? Just message me on. Is it visible to all participants?
Yes, sir.
Okay. So this is what we are basically focusing on. Just have a look over it. And we can ask a question over it. We are having input. We have performed convolutions. Why we have performed convolutions? We also know that. We are performing feature maps in different sections. So we have done subsampling. We have done convolutions. We have performed subsampling again. And then we are having a fully connected output. So that's my point is, if we are doing this, we have to perform this like that. Fine. So let me share it with you, that particular thing with you so that I can explain it with you. So just have a look where the basic concept is we are having convolution network which is totally based on the brain. Fine. Now what we are doing, if we are considering this particular image, fine. If we are considering this particular image, we are having everything done in this. Pooling layer. We are having a fully connected layer. Fine. But what is the point of doing this? We have gone through with convolutional layer also. We have done with the padding also. But what is the point in getting it? Even if you are working on Anaconda, even if you are doing deep learning libraries over it, fine. But what is the point in using it? So basically, the image shows you that you feed an image as an output to the network, which go through the multiple convolutions. Why we are going through the multiple convolutions? We are going through the multiple convolutions just to make sure the answer should be efficient enough to get. Otherwise, why shouldn't we do it manually? If we are working on some different algorithms, there is no point of getting such kind of thing. But what are all these concepts? Fine. The convolution layer computes the output of neuron. Fine. We all know that. So that are connected to the local region, what we are focusing on. But when we are talking about objective, so what is objective of subsampling? Any answer for that? Just paste it in the comment thread if you are having. Even if we are doing it in image processing or machine learning, what is subsampling means to you? Why we are doing it? Any answer? Why we are doing subsampling? Whatever we have discussed so far, just answer with that. Anyone? Anyone is doing research in CNN or their PhD topic or reduce the size, right, Saraswati ma'am? But I want to know why we are reducing it. Why not to go through with the same size we are having? What is the point? Just in one line you can say. I'll wait for that so that I can have some topic to discuss it with you. Why we are reducing it, ma'am? If we are not reducing it, what will happen? To simplify, okay, fine. So
it may result in overfitting of the model.
Yes, sir. Right. I'm just explaining. Yeah, I'm explaining it in a very better way, that what it will be, I mean, provide to you if you are doing it. Size of data done. What if, Dipti ma'am, if we are using reduced size of data before only, or Saraswati ma'am? Complexity is a very, I mean, good reason. I'm agree with it, Saraswati ma'am. Yeah, this is the right answer. I mean, one of the right answer, resolution. Resolution, Pooja ma'am. So the resolution is a good parameter to go further. Apart from that, anyone? A reduction of the feature map sizes, Ramya ma'am. Okay, yeah. So we all are very correct, whatever we have done so far. So we all are very correct to that. But if we are talking about the objective, you have heard about the things called underfitting and overfitting. Now, recalling it, if I'm right, you must agree with me over that. Overfitting will also get your data, distorted in a bad manner. Underfitting, also will distort your data in a bad manner. So excess of everything is bad. So the basic objective of subsampling, and we are doing it again and again, as you can see in the figure. This is the basic figure provided by internet. Fine. This is the basic figure we are having. So we have applied pooling over it. We have applied padding over it. So it will help in reducing overfitting in this case. This is the one line answer to it. Everything, complexity, resolution, everything will be considered in overfitting cases. Agree to me or any question? Agar aap agree karte hain, then just let me know. Then one of the technique of subsampling is pooling. So with this technique, we can select the highest pixel. So if it is max pooling, you are taking highest pixel. If it is mean pooling, you are taking the lowest pixel. But there is no concept of mean pooling because lowest pixel cannot make the things change for you. You have to go for the highest pixel value. If you have considered the highest pixel value or highest threshold, then the things will be okay for it. For example, in a area like Jaipur or Rajasthan, we are having a very tall and very long doors on roads. That's because they are having camels there. So they are having the maximum threshold that a camel could pass, a human can also pass. That's my point is. So that's why in max pooling, we have taken a highest value of the, for the reason, depending upon the size. So I must tell you, the size is very important. So in other words, max pooling takes the largest value from the window of the image. Fine. So we have gone through with 3 into 3 data pixel. So we have to take 3 into 3 region, and intensity value or maximum pixel with intensity value from 3 into 3 region only. But you are right. All the respected faculties have answered, or research scholars, they are right at their own place. That the pooling layer then works a lot like convolution layer. So there is no difference between pooling and convolution in this context. So this is my basic point that I want you to drag your attention at. That we are having same pooling layer concept and we are having same convolution layer concept. So what we are doing, we also take a kernel. Fine, we are also taking a kernel. We have discussed it in the PPT part, or a window, a sliding window or a stride that move it over the image. The only difference will be the function that is applied to the kernel. The image window is not linear. Please write it down. The image window is not linear. So we are taking it from that place. So now the last part is, what is the objective of fully connected layer? What is the objective of that? So if we are having fully connected layer, it has or it is to flatten the high level of feature. We have to consider high level of feature first. If we have considered high level of feature that are learned by convolution layers, the combining of all the features summed it up, it passes the flattened output to the output layer. Fine. So where we are having softmax classifier in Python, if you are using Anaconda, or a sigmoid function to predict the input class level. So anything you can go further with. Anything. Fine. So even if CNN you are going through with what is CNN, what we are doing in SGT, forward run or stochastic gradient descent. So we are having lots of concept which is not possible to finish it in a single class. There is error back propagation. Fine. So there is input layer, output and notation we have covered. Fine. So we have covered everything in the basic part, that what is convolution. So if we are having, we have gone through with 3x3 image, 6x6 image. Now my question is, suppose we are having an input image of 3x4 and the kernel size is of 2x2. Then what will happen? Any answer for this? I'm waiting for your answer. Ramya ma'am has sent something, a reduction of feature maps. Very good. I'm agree with you, ma'am. As we move through, the network enables the possibility of reducing spatial. What is spatial resolution to you, ma'am? Is it limited to 3D or something like that? Or you have some other answer to say? Tell me. Suppose we are having variant thing. My question is, I'm repeating my question. Suppose we are having variant thing, 3x4 matrix, and we are having convolution size of 2x2. So what will happen in that case, according to you? You must know, Ramya ma'am has told me the spatial concept. So they must know about the spatial locations also. So if we are having different types of kernel, like it is not uniform, now not like 2x2, not like 3x3, not like 4x4, then what will be done? Then there will be overlapping condition. And when there is overlapping condition, there are chances that we will perform misclassification. So if we overlap the convolution kernel on the top of the input image, we can compute the product between the number of at the same location. What Ramya ma'am have just told me, that spatial location. So at the same location in the kernel, we can able to compute the numbers. So we get a single number of by summing it a product together. So if we overlap the kernel with the top left region in the input, the convolution result at spatial location, that is could be 1x1 plus 1x4 plus 1x2 plus 1x5, that is the thing. So what we are going to do, we keep move the kernel down till it reaches the bottom borders. And then we return to the kernel to the top, and we are doing the same thing. So what we are doing here, we are doing push pop like we are doing in a stack. So nothing is getting very much differentiated what we have done before. If we are having a very good concept of algorithm to proceed further with, we are having no issue in dealing with such kind of situations. So when it is convolution layer, what you are seeing on your screen, so multiple convolution kernels are usually used. Usually multiple kernels. And we have to sum it. We have to sum it down all the products. And mostly, as you can see, we have denoted all the kernels as F. So F is an order of 4, and then we have to go for tensor. Fine, then we are having different values, but we have to actually familiar with what convolution is all about, how we are setting the convolution thing. So we are denoting all the convolution with F. On what index variable we are using, the index variable should be lie between 0 to maximum. 0 to maximum, if I'm saying what is maximum, 0 to maximum height, 0 to maximum weight, fine. And it should be, I mean, distance is always greater than 0. It shouldn't be in, in negative, or it shouldn't be in 0. Fine. So that's my whole thing is why we are doing it and what is the point of getting it done. Fine. Now there is a question: what is biological connection of CNN? Why we are doing it biologically? Whenever you are performing CNN, you must agree with me on that. So we are performing image intensity gain. Done? The basic thing I'm trying to reach you. So each pixel is represented by number of 0 to 255, right? Units, 256 into 256. So basically there are 4 major operations in CNN. That is convolution, that is activation map, that is max pooling, because why mean pooling is not there, I have already explained you. That is flattening, and the 5th one maybe can be fully connected layer. What is showing in the output part? Fully connected layer. Fine. So I have represent the pixel representation of input image, pixel representation of kernel in the PPT in the previous slides. I have explained padding in the previous slide. I have explained max pooling, that what is max pooling. In max pooling, we have a window passes over an image according to the set stride value. So set stride value we have set. So what we are doing at each step, the maximum value within the window is pulled into the output matrix. That is what max pooling is all about. So it is a very simple concept, but we need to know it. Flattening is what I have explained you in PCA. PCA can be used for flattening. Fine. So after multiple convolution layer or downsampling operation, the 3D representation of image is converted into feature vector. Fine. So if we are having 3 into 3 or n into n, it should be n square into 1. That is passed to the multi-layer perceptron to output possibilities. Just find it out the output possibilities from this multi-layer perceptron. Fine. So these can be understand like this if we are talking about flattening. I'll just let you know that how it can be done. So this is flattening we are performing. This is what flattening is all about. So the rows are concatenated, as you can see, from a long feature vector, and if multiple input layer are present, its rows are also concatenated in form that even longer feature vector. Getting my point? So the first image will tell you that what is, what is a fully connected network. As you can see over here, just have a look over it. What is fully connected? Fine. So the question is, somebody will ask you, what is fully connected? Flattened feature map, you have got, flattened feature map. Now it will be passes through the neural network, and this particular step made up of input layer and fully connected layer and the output layer. So fully connected layer itself is not output layer. Getting my point? Fully connected layer is not itself the output layer. There are further predictions for the output layer also. The fully connected layer is similar to the hidden layer. Agree with me? What I think, the fully connected layer is similar to hidden layer in artificial neural network. But in case of CNN, the scenario is getting changed. It is hidden layer in ANN, but it is fully connected in CNN. It is fully connected in CNN. So the output layer where we get the predicted class, the information is passed through the network and the error of prediction is calculated in that way. So then particularly that calculated error is back propagated through the system, and this will definitely improve the prediction. So what softmax activation function will do, the output of this dense layer is therefore passed to the softmax activation function only. Fine. So this is the role of softmax function. Basically, apart from this, other roles are secondary. Fine. So we can understand it that how flattened data we are getting and how we are dealing with that flattened data. We can also have this. Fine. So this flattened data we are having, and then we are having fully connected layer, and then we are having output predictions. That will make the things much better than what ANN was providing. So comparatively, CNN is providing the greater things, but it shouldn't be used as simulator. Something, some function, some mathematical things should be made by yourself to make it done. Otherwise, it would be a wastage of time and nothing else. Fine. So if we are asking, if I am asking that why to convolve, why we should convolve, why we are getting at convolution results using two different kernels or more than two kernels. Fine. Whether we are going on an image with some horizontal edge or with some vertical edge, kernel should be used in that case also. Fine. So any kind of thing, if you need to cover, we need to cover the convolution network. Now I'll share the PPT part with you. Let me share the PPT with you. Now you would be able to understand that what I am trying to say. These are the convolution we have discussed. These are the things we are having. So we can able to project our own algorithm after this. If we are performing it, if we are getting it done, then we are able to. If our basic concept is okay, then we can add something into it. Otherwise, we cannot add any value to it. That's my point. Now, what is flattened image? What is output? What is fully connected? Now you would be able to understand that. I mean, I hope so. If not, you can ask me. You can mail me for that. Fine. So these are the things we are having. Filter 1, they are having their own parameters and circumstances. Then there are the things, just have a look over it, what we are getting done, how we are detecting the things by flattened image to fully connected. So only connected to 9 inputs, not fully connected now. Getting my point? Now see it. Again, we are on the same page. I mean 16:6 image, fewer parameters we have taken, and then we are having the same thing. We're having the same filter, that filter 1, and then we're having the different values for fully connected. Just have a look. So these are the shared weights. Fewer parameters, and even fewer parameters we are having some different values in that way. So the whole CNN is like that, even if we have done it in image detection or object detection also. So we are having an input probe image, that we are having a fully connected feed forward network, taking the things and feed it forward. Then we are having the convolution. You all know about what is convolution. I have explained it. You all know about max pooling, taking the maximum threshold. I have explained it. Again, we have applied convolution. I mean, sampling is applying again and again. Why we are applying it? We know it, and we can repeat it for many times to reach at the flattened part. Why we have to reach at flattened part? Because that is not the end of the road. We have to get the output after fully connected feed-forward network also. So whether it is cat or dog, it can be done through the whole processes. A single process won't let you know that it is a cat or it is a dog, because we are playing with matrix, my dear friends. We are not playing with the images actually. So this is max pooling example. What I have explained to you, we have to take the maximum layer so that the maximum value can be done. Fine. And then we are having the values vanished from that place. Whatever will be left, that is called subsampling. Subsampling pixel will not change the object. It will not change the object. Getting my point? It is not changing it. It will have the same thing. I mean, dimension should be changed, but the information shouldn't be changed. So subsampling pixel will not change the object world. as you can see it over here in this slide also. Am I clear to everyone? So we can, subsample the pixel to make images smaller. That's the basic thing is. Complexity will ultimately decrease. That's, very much clear. I'm agreed to it. So fewer parameters to characterize the image. We have to go for parameters only. We don't have to go for basic information like what is the matrix, what is the dimension. We have to go for the parameter, what parameters we have taken. That will purely change the game. So a CNN compresses a fully connected network into two ways. I have already told you, number of edges will be reduced. I have told you that reduces the number of connections. Shared weights on the edges. This is the second method. Max pooling, I have explained to you. So again, this is max pooling for you. We are having a 6x6 image. We have applied convolution. Then we have applied max pooling. So new image, but a smaller data set. So we are having 2x2 specific content of 6x6 image now, so that we can work it well and we can have a better understanding that what is getting done. So each filter is a channel over here. I want to mention it in blue. So you are having this. So this is the whole CNN and we can repeat it many times. How it is getting done, how max pooling is getting done, just have a look. What you are having over here, I'm moving the cursor, a new image we are having. A new image we are having, smaller than the original image. That's what Ramya ma'am has also told. That's what Pooja ma'am has also told. The number of channels in the number of filters. So we have to consider it for this particular case. Done. So we are getting it in a very, basic way, basic of CNN. What is flattening? I have just explained you. This is flattening. So I have made the same example in PPT also for you. This is fully connected for feed-forward network, same example. And this is the kernel example. We are having input, convolution, max pooling, convolution, max pooling. Fine. So you can perform this kind of function in that case. Fine. So this you have to use convolution 2D. So we can have a separate class for coding also if you are trying to do. But these are the basic things you must know, everyone. And you should know because we have to teach your students also. But in this case, there are 25 3x3 filters, as you can see it over here. What I have underlined. Clear to everyone? Then we are having input shape 28, 28, 1. What will input shape 28, 28, 1 X, Y, Z. Fine. So 28 into 28 pixels, 1 black or white. Fine. 3 RGB. I have explained it to you. So that's how we will make our function when we are coding it. We're doing it in Keras. Now the convolution part is done. Max pooling. Max pooling. For max pooling, we have to use the function, inbuilt function, that max pooling 2D. If we are performing in 2D, it should be like this. Done. Done. Fine. Max pooling, we all know. Convolution, we have to use the same function. Model 12, we have to use it for model 12. So we have to add a function and then convolution 2D. Then we have to pass the dimension. We have passed the dimension. It should be 50 into 11 and 11. Then we have to use max pooling function again. And then we are having the different answer again. So how many parameters for each filters? The question is, how many parameters for each functions? 9. Getting my point? How many parameters for each filter? 25 into 9, 25. Getting the answer? The same thing. Now we have to use flattened. Fine. So for flattened, we are using it for model 12. Then we have to add and the flatten function. Getting my point? What we are getting into connect, after getting it multiplied and summed, what would be done? 1250. Now we are having fully connected feed-forward network. What 1250 is getting on. Now you can see it here. So we are using dense function. We are using activation function. We are using activation function again with having some different values. with having, if you are using it in a single quoted term, then you are using it as a function, whether it is ReLU, whether it is softmax. So we can have a separate class for ReLU and softmax, not to worry. Fine. There are lots of things. I mean, neural network next move could be anything. So we have lots of things to discuss. But I would like you to ask some question because we are running short of time. As I am explaining the same thing in the PPT also, what I have explained it to you in doc file. Fine, and I have underlined it also. So it is used in speech recognition also. Fine, text classification also. So anything you can use it. So you just let me know. I mean, if it is okay for you or not. Yeah. So I'm open for question now. If you are having any, you just let me know because I hope we are supposed to finish it by 11, I guess. Do we have time, sir? We can continue it. Otherwise, uh, let's have a questions and answer session. And your feedback, of course, so that I can improve myself in that way. I'm open to your question. Please ask if there is any. Anand sir, am I audible to everyone?
Yes, you are, sir.
Yeah. So just ask me if you are having any doubt, any question from the whole thing. I would like to answer you.
Sir, if one wants to do additional feature extraction while using CNN for image classification.
That's what I'm explaining, sir. I mean, when we are having bulky data to work on, or when we are having multiple features to detect on, then we are, we are supposed to use CNN. Otherwise, machine learning is very much fine to me. I mean, or anyone, machine learning is very much fine to go further with, sir. CNN means you are performing multi-purpose thing, multi-purpose feature detection. As you can see it over here, we are performing different things in a single time. We are doing not speech recognition. So just to get exactly what we are wanting, we have to use multi-purpose algorithms, which was not possible in machine learning. That was having the machine learning limitations. That's why we have used CNN, sir. Otherwise, CNN, even CNN is not having something that we can approach our own results into it. So we must have to focus on our own algorithm or own results, sir. If I'm clear, let me know.
You are clear, sir. But in this case, what I'm trying to do is that I still want to optimize my results using something like particle
Sir,
optimization.
what I am getting from your point, you are working. You are a master's student or PhD student or a faculty.
PhD student, sir.
Okay, PhD student. Where are you getting your PhD from?
From Ladoke Akintola University of Technology, Nigeria.
Okay, great. So what I am telling you, have you proposed some algorithm into it? May I have some idea, some overview that what you have proposed, sir, and what dataset you are working on?
I'm actually working on a face recognition dataset.
Okay.
So, and I'm
Then
planning to.
face recognition can be done in machine learning also. What made you to go for CNN if you are doing face recognition, sir? Because I have also done face recognition in my MTech and my PhD time, but I have not used CNN in that case. I have used some altered concept of existing algorithm. So even if you are, approaching on face recognition only without getting on some other features or some dynamic face recognition technique, you should use CNN. Otherwise, it is not dynamic, or you are focusing on some proposing algorithm, you should go for machine learning algorithm if your guides is okay with it, sir. Otherwise, you won't able to propose any new algorithm of yours because we are basically changing the layers and we are basically playing with the filters, strides, and CNN, sir. Any other question? You can pass the question in comment thread also.
Participants can also post their questions in the chat box.
Yeah, Sanchi Grover, I will share the PPT with the management who has organized it. They must share it with you, not an issue. Apart from that, any other question, any doubt?
I think there is no doubt from participant side.
Okay.
Okay, so many thanks for your brilliant session today, sir. It's a great presentation with a lot of yes, it's a great presentation with a lot of specific and helpful information. Thank you, sir.
Yes, thank you so very much.